Hey everyone, welcome back. Today, we're covering Starlink satellites falling to Earth and Avi Loeb's warning, the interstellar Comet 3 I-Atlas near Mars, organic molecules on Enceladus, an asteroid closer than the ISS, Mars hurricane winds, and China's moon discovery. Let's get into it. Let's start with the most pressing issue. Starlink satellites are falling to Earth at alarming rates, and Harvard astrophysicist Avi Loeb is sounding the alarm. According to Harvard Smithsonian astronomer Jonathan McDowell, 1 to 2 Starlink satellites are deorbiting every single day in 2025. And that number is expected to climb to 5 per day as more satellites reach the end of their 5-year lifespan. Here's the scale. Of the 12,000 satellites currently in orbit, about 8,000 are Starlink. SpaceX plans to expand that to 42,000 satellites. Amazon is launching 3,200 for Project Kuiper. China is building its own constellation. By 2030, we could have 100,000 satellites in low Earth orbit. And this is what Avi Loeb said for Morning in America.
The Earth is big, and 71% is covered by oceans, so the chance right now of getting killed by a fragment from a satellite re-entry is not large, But,
and this is critical, Loeb explained that these satellites don't just vanish. When they re-enter, they burn up in the atmosphere, releasing metals.
Not to speak about the possible pollution of the atmosphere with the evaporation of all these metals into it.
The satellites are designed to burn up completely during re-entry. But McDowell told EarthSky, "We're not sure we really believe that they really burn up, but at least for the most part they melt. The truth? Some fragments are reaching the ground. Then there's the Kessler syndrome risk. Scientist Don Kessler warned in the 1970s that too many satellites in similar orbits could trigger a chain reaction of collisions. Loeb reinforced this warning. Once you have too many out there, they might collide by chance. Think about it. One collision creates debris. That debris hits other satellites. More debris, more collisions. A cascading catastrophe that could wipe out GPS, communications, weather monitoring, and financial systems worldwide. The FAA estimates that by 2035, some 28,000 fragments from Starlink satellites could survive re-entry each year. That's 28,000 pieces of metal raining down annually. Research is underway right now to determine if we're already damaging the upper atmosphere. McDowell said, "If it comes back that we're already doing damage to the atmosphere in this way, we're going to have to rethink some of our disposal strategies." But here's the problem. By then, it might be too late. We're launching faster than we're researching the consequences. From Earth's orbit to the edge of our solar system, 3 I-Atlas, the interstellar comet that's only the third object ever confirmed to enter our solar system from beyond, just flew past Mars last week. And we have photos. The European Space Agency's ExoMars Trace Gas Orbiter captured rare images on October 4th, showing a fuzzy white dot moving through space. This is the comet's nucleus, a solid core of ice, rock, and dust surrounded by a glowing cloud of gas called the coma. Since 3 I-Atlas was first detected in July, it's attracted massive interest. And yes, Harvard's Avi Loeb has raised questions about whether it could be artificial. But there's no scientific evidence supporting that claim. What we do know is fascinating enough. 3 I-Atlas is now heading towards the sun, reaching its closest approach on October 29th, just 2 weeks away. It'll pass about 170 million miles from Earth, so there's zero threat. But its close flyby of Mars, just 18.6 million miles from the ExoMars orbiter gave us this unprecedented opportunity. Here's what makes this challenging. The orbiter's camera was designed to photograph Mars' surface, not objects millions of miles away. According to Nick Thomas, the principal investigator, the comet was 10,000 to 100,000 times fainter than their usual target. The fact they captured it at all is incredible. NASA's been tracking it with Hubble all summer, and now James Webb Space Telescope, the Parker Solar Probe, and multiple observatories are preparing to observe it. 3I Atlas will disappear behind the sun's glare for the next several weeks, but should emerge visible again by early December. Why does this matter? Because the two previous interstellar visitors, Oumuamua in 2017 and 2I/Borisov in 2019, gave us glimpses into alien solar systems. 3I Atlas carries chemical signatures from a star system we'll never visit. It's a messenger from another world. From interstellar visitors to one of the most promising places for life in our own solar system, Saturn's moon, Enceladus. On October 2nd, researchers from Freie Universität Berlin published bombshell findings in Nature Astronomy. They discovered new complex organic molecules and ice grains ejected from Enceladus's subsurface ocean, and these could be precursors to life. Here's what's wild. This data is from the Cassini mission, which crashed into Saturn back in 2017. 8 years later, we're still making discoveries from that probe. The researchers found aliphatic compounds, cyclic esters, ethers, and nitrogen-oxygen-bearing compounds. If that sounds technical, here's what matters. On Earth, these exact molecules are part of chemical reaction chains that create even more complex molecules needed for life. The key detail? These molecules were found in fresh ice grains, material that erupted from the ocean through the tiger-stripe cracks and hit Cassini's instruments within minutes. This isn't radiation-damaged material that's been floating in space for years. This came straight from the ocean. Enceladus now has everything needed for life. Liquid water ocean, energy source from hydrothermal vents, organic molecules, and the right chemistry. ESA is planning a return mission in the 2040s with both an orbiter and a lander to search for life directly. The building blocks are there. Now we need to find out if life is too. Next up, Planetary Defense got a wake-up call on October 1st. An asteroid designated 2025 TF flew over Antarctica at an altitude of just 428 kilometers, closer than the International Space Station, which orbits at about 370 to 460 kilometers. The asteroid is only 1 to 3 meters across, so there was no danger. Objects this size burn up in the atmosphere and might drop small meteorites. But here's the concerning part. It was first spotted by the Catalina Sky Survey after it had already passed Earth. ESA's Planetary Defense Office quickly observed it using the Los Cumbres Observatory Telescope in Australia. The fact they tracked down a meter-scale object in the darkness of space when its location was still uncertain is impressive. But the fact we missed it on approach is a reminder that our detection systems aren't perfect. This is exactly why projects like the Vera Rubin Observatory are so important. We need better early warning systems for near-Earth objects, even the small ones. From near-Earth asteroids to the red planet, Mars might look calm from orbit, but new research published October 9th reveals it's a world of fierce winds and dust devils moving at hurricane-like speeds. Using deep learning AI to analyze thousands of satellite images from European orbiters, scientists discovered that Mars' dust devils, those swirling vortices of dust, can reach speeds comparable to Earth's hurricanes. This matters for future Mars missions. Dust is one of the biggest threats to Mars rovers and habitats. It accumulates on solar panels, reducing power. It infiltrates equipment. The 2018 dust storm that killed NASA's Opportunity rover lasted for months and covered the entire planet. Understanding Mars' weather patterns, including these high-speed dust devils, is crucial for planning human missions. Where should we land? When should we plan surface activities? How do we protect habitats and equipment? This research also helps us understand Mars' climate history. These dust devils play a major role in Mars's atmospheric dynamics, moving heat and moisture around the planet. Finally, China's Chang'e 6 mission just revealed something unexpected about the moon's formation. Samples from the lunar far side, analyzed and published October 3rd, show that the far side formed from cooler magma than the near side. This confirms that the moon's interior is not uniform. It has distinct geological provinces. For decades, scientists debated whether the near and far sides of the moon formed differently. The far side has thicker crust, fewer maria, those dark volcanic plains, and completely different geology. Now we know the temperature difference during formation is a key factor. This discovery helps us understand not just the moon's formation, but planetary differentiation in general. How do rocky bodies separate into distinct layers and regions? Why does one hemisphere form differently than another? India's planning to return far side samples with Chandrayaan-4. NASA and ESA have similar missions in development. The moon's far side is becoming one of the most important scientific frontiers in planetary geology. If you enjoyed this, hit subscribe for weekly space news, drop a comment with which story shocked you most, and I'll see you in the next one.